In this video, we'll be discussing constraint again, but these constraints will be slightly difficult. So this is an advanced video, and you must have watched a constraint basic video before watching this video. Okay, so in this first example, there are two strings. One string is with block 2 and 3, and the second string is with block 1. So again, from a fixed line in the direction of their line of motion, we just drop their locations as xp, x1, x3 and x2 for the respective blocks and pulleys. And we can say for string 1, x1 plus xp will be length 1. In differentiating, we get this relation. And for the lower string, this is the lower string, this one. And for the lower string, we can say this length, see the cursor, this length will be x2 minus xp, this will, and this length will be x3 minus xp. So we can get by differentiating, as x3 is decreasing, x3 is increasing, we will replace it by plus v3, and x2 is also x2 is decreasing, so minus, and similarly xp is decreasing in the assumed direction of velocity, so it will be minus. We'll get this relation. And just from equation 1 and 2, this is equation 1, this is equation 2, we can get the relation between v1 and v2 and v3 as this. Okay, now move on to the alternate method, which is again the tension method or virtual work done method, in which we'll just draw the tensions and take their dot products with their individual velocities, and the sum of all these dot products will be 0. This method is known as virtual work done method. So have a look at that. 2T is the tension on block 1, T is the tension on block 3, and T is the tension as well as on block 2 also. Just have a look. This is T, this is T, this will be 2T, so 2T will be transferred to block number 1. So again, coming back to the same point, you can say these tensions and velocities are opposite, so minus sign, again minus sign, and they are in same direction, so plus sign. Eliminating T, we get the same relation as we got earlier. So this method is quite fast. Just by looking at this diagram, we can say this will be 2v1 with minus sign here. This will be single times v3 because t has a coefficient 1, so minus v3. This will be single times plus v2 because same direction and single coefficient of time tension, so we get this. In these two examples, we'll just see the tensions and try to get the constraint relation directly. So look, the tension in the string is assumed to be T, so it has single coefficient, will be same direction, it will be plus V1. And in this string, the tension will be T by 2. T, and these two strings will have T by 2 tensions. So on this block, there's T by 2, and velocity is assumed to be downward, opposite direction, so minus V2 by 2. 2 is the coefficient, 1 by 2 is the coefficient of tension, equal to 0. Similarly, in this, let the tension in this string is T, so on this string will be 2T, 2V1 with a plus sign. Here it will be 2V2 with minus sign, opposite directions, it will be single time V1, V3 with minus sign, equal to 0. When one block moves over a wedge, then these type of constraints are quite famous. So in this constraint, we have to uh, form this constraint from this point, which is on wedge number 2. So this will be the location of block 1, x1 with respect to 2. This is the location of block 1 with respect to 2, and this distance is x2. So length of the string can be sum of these two distances. On by differentiating again, we can give the sign. The differentiation of this will be velocity of 1 respect to 2. Okay, so to get the velocity of 1, we can add velocity of 1 respect to 2 with velocity of 2 by this diagram. This is the direction of velocity of 1 respect to 2, whereas this is the direction of velocity of 2. The resultant will give you the velocity of block 1, which will be 2v naught sine theta by 2. You must have a knowledge of vectors to get up to this result. Similarly, in the second example, we can see that again the block is moving on the wedge number 2, and we have to form the constraint from this point. This is the location of block 1 respect to 2. This is again x2 from a fixed point. So this will be x2 by cos 60. So it can be 2x2. So the total length of the string can be x2 plus 2x2 plus x of 1 respect to 2. So 3x2 plus this. On differentiating, we have assumed that the block is moving downward and the wedge is shifting towards right. So depending on their uh, trend, whether x is decreasing or increasing, we gave them signs. And again, v1 will be velocity of 1 respect to 2 plus velocity of 2. Velocity of 2 is there, velocity of 1 respect to this is there. We can get the result by just using vector addition. Another similar example is there. uh, you can have a look at the example. Again, we have to form the constraint from this point. This is the common point, and in the next example we'll feel the similar point from which we'll form the constraint. So x of 1 respect to 2, this length will remain constant. We can even neglect that because on differentiation it will vanish. This is x2. Again, this distance will remain constant, L1, and this will be L1 minus x2. As the block is moving, wedge is moving with v2, and the block is moving along this direction with the velocity relative to 1, relative to 2. So just by adding these x2, L1, this L1 plus L2 plus L1 minus x2, then x of x2, this x2, then x of 1 respect to 2, we get the total length of the string as capital L. On differentiating, we can get this x2 is already been cancelled. v of 1 respect to 2 is 0. Means the block will not at all move relative to the wedge. If wedge moves towards right by x2, the block will also move with the wedge by an amount x2 towards right. So velocity of 1 is nothing but velocity of 2, as velocity of 1 respect to 2 is 0. In the next example, we can see that this is the setup, and this block, which is block number 1, again we have to form the constraint from this point. So x of 1 respect to 2, x2, this is fixed length, this length will be x2 minus L2. If we can say this length is something, okay, or this length is L2, this from this point, center of the pulley, to this vertical line, which is fixed distance L2. So just by adding these distances, we get this relation. On differentiating, we'll get this, and velocity of 1 again will be vector sum of velocity of 1 respect to 2 plus v2, 10 in downward direction, 5. It is given that this wedge 2 is moving with velocity 5. We can get the value of v1 by 2 as 10. 10 will be downward, 5 will be right, and the resultant will be 5 root 5. The next type of constraint is velocity. When two bodies are in contact, velocities along common normal should be same. So the wedge is pushed with a velocity 20, we have to find the velocity with which a sphere will move in upward direction. So just draw this triangle. It is given that at this point the contact is at a distance r by 5 above the base. So this will be r minus r by 5, which is 4r by 5. This is radius r. We can get this value of theta as 37. The other angle will be 53. We can take the component of velocity of sphere along common normal, which will be equal to velocity component of velocity of wedge along common normal by just substituting the values. 20 cos 53 because 20 is in this direction and common normal is this. So 20 cos 53, velocity of sphere is in upward direction, common normal is this. So Vs cos 37, we get Vs as 15. This is an awesome example in which there are two spheres of different radii. Radius of sphere B is given as 5, whereas the distance between the center of A and this wall is 17, and center of B and this wall is 19. These angles are given as 30 and 60. So we have to find the ratio of their velocities, or the relation between their velocities. So we can say this distance will be 5 as the radius of sphere B is 5. So this length will be 12. 17 minus 5. So I just draw this as 12. And this will be, let the radius of RA is RA. Then this length will be 19 minus RA. This will be perpendicular, as this will be this much angle. And the distance between their centers will be 5 plus RA, radius of B plus radius of A. As this is an right angle triangle, you can use the Pythagoras theorem to get RA as 10. Again, using the same triangle, velocity of A will be in this direction and velocity of B will be in this direction. Look at the diagram. VP will be in this direction, VA will be in this direction. Theta and theta 2 are known to us, as the triangle is right angle and all sides, we know all the sides, 12, 9, and this will be 9 plus 5, which is 14. So we can get the component along common normal. This is the common normal, the line joining the centers. So VA cos theta 1, VB cos theta 2. By just replacing the values of cos theta 1 and cos theta 2, we get 12 times VA is 9 times VB. Thank you.